Hey there, everybody. Welcome to this video. This is the video for Module 4, and Module 4 deals with the meaning of a fraction as well as equivalent fractions. So we're going to go through a few example problems. So I will go ahead and share my screen and we will get started. All right, so our first problem for this video deals with taking a fraction and basically kind of what we might call expanding the fraction, which means rewriting it with a different denominator. The cool part about fractions is that you can have fractions that have different numbers in the numerator and in the denominator, but are still equivalent to one another. So essentially what we're going to do here in this problem is we're going to take the fraction 4/5 and we're going to rewrite it so that way it's now going to be a fraction out of 60. All right. So basically what we're going to do to get started here is we need to figure out what do we have to multiply 5 by the denominator to get a new denominator of 60. So in this case, 5 times 12 is 60. So the key thing with equivalent fractions is whatever you multiply the bottom by, make sure you do the exact same thing to the top. So if we multiply the bottom by 12, we're going to multiply the top by 12 as well. So when we do that, we get the value 48/60. And 48/60 is equivalent to 4/5. They have the same overall value. The difference being with 48/60 is that your whole amount is cut into 60 parts and you have 48 of them, as opposed to cutting it into 5 parts and having 4 of them. When all said and done though, those values are equivalent. So our final answer is 48/60. Again, the key thing to remember is when you multiply the top and the bottom by the same thing and your fraction will be equivalent. All right, problem number 2 is basically working in reverse. This time what we're going to do is we're going to take the fraction 72/80 and we are going to reduce it to the lowest terms, which basically means we're going to write it in an equivalent form. We just want to have smaller values for the numerator and the denominator. Okay? So like we said before, whatever you do to the top, you want to make sure you do to the bottom. This time though, instead of multiplying, we're going to divide. So again, as long as you divide the numerator and the denominator by the same thing, you're going to end up with a fraction that is equivalent to what you started with. So let's start by finding something that both 72 and 80 can be divided by, and in this case, they can both be divided by 4. So that's just a number that we could potentially use. When we do that, we end up with the fraction 18/20. 72 divided by 4 is 18, 80 divided by 4 is 20. Now, 18/20 is a smaller reduced value. Again, the value doesn't change, the numbers are smaller. But 18/20 is not quite in lowest terms because there's still more that I could divide by. In this case, I can divide 18 and 20 both by 2 and get the fraction 9/10. When I get to 9/10, finally I get to a fraction where there is not a number that I can divide both the numerator and the denominator by evenly. So that tells me that I'm at my lowest possible version, I guess, essentially, of the 72/80. Now, in this example, it took me 2 steps to get from my original fraction to my reduced fraction in lowest terms. If you want, you can do it in just 1 step. For example, 72 and 80 can both be divided by 8. Okay, when I do that, 72 divided by 8 is 9, 80 divided by 8 is 10. That gets me to that same reduced fraction just in a single step rather than in multiple steps. And if that's the case, that's totally fine too. it doesn't really matter how many steps it takes you to get from the original to the reduced fraction, as long as you get there. All right, so if you can do it in one step, that's the quickest, but if it takes you several steps, that's totally fine as well. Regardless, our final answer is 9/10. When all said and done, the reduced version of 72/80 is 9/10. All right, so the first two problems deal with expanding and reducing fractions. The next problem deals with mixed numbers and improper fractions. Mixed numbers and improper fractions are basically two different ways to write the same value when you have a fraction and a whole number kind of put together. All right, so the first problem we're going to look at is what happens when you have a mixed number. How do you convert that into an improper fraction? Okay. Basically, the process is fairly straightforward. What you start with is you take the denominator of the fraction and you multiply it by the whole number. Okay, so 3 times 4 gets us 12. Then you add to that answer whatever the numerator of the fraction is. So we're going to take the 12 and add 2, and so we end up with 14. Okay, 14 becomes the numerator of the improper fraction. And then what you do is, for the denominator, you keep it the same. Okay, so since the original denominator was 3, the denominator for our answer is also 3. And so 14/3 is our improper fraction. What makes it improper is the fact that the numerator is larger than the denominator. In a typical fraction, that's usually not the case. Its numerator is usually smaller than the denominator, but improper simply means the numerator is bigger. And again, what both of these numbers, the original 4 2/3 and then the 14/3, what these numbers represent is a situation where you have a whole number portion and then the fraction of an additional portion. So 4 2/3 originally meant that you had 4 whole whatever, you know, so you're talking about pizzas, 4 whole pizzas, and then 2/3 of another one, okay? 14/3 basically means that you've got your pizzas cut into thirds and you've got 14 slices, 14 pieces all together. No matter how you put it together, you end up with the same amount, okay? So our number, original as a mixed number, is now written as an improper fraction, 14/3. And for our final example, what we'll do is go in reverse, do the opposite of that. This time we're going to start with an improper fraction. We want to convert it to a mixed number. Basically, what we're going to do is we're going to do long division. All right. So what we're going to do is we're going to take the numerator and divide it by the denominator. 18 divided by 7. And so there's the long division shown on the screen for you. It goes in there 2 times. What happens though is we have a remainder. We have 4 left over. 7 does not go into 18 evenly. And so what we do is with that remainder, instead of writing like remainder 4 or trying to do a decimal or something like that, what we simply do is we take the remainder and we write it as a fraction over the divisor, over the 7, or the original denominator. Okay? And so what we end up with is the whole number 2 and then 4/7 as the fraction. So here's our mixed number, 4 2/7. Okay? Again, 18/7 and 2 4/7 are equivalent to each other. They mean the same thing. It's just that one is written as a whole number and then the fraction of another piece. The other one, the original improper fraction, is written as the number of pieces out of the size or the amount that each what each piece represents. All right, so there you go. Those are some examples to help you when it comes to working with equivalent fractions. We talked about reducing and expanding fractions, so they have different denominators. Remember, with equivalent fractions, they are still equivalent. They're just written with different values. The key thing to remember is either multiply the numerator and denominator by the same value or divide the numerator and denominator by the same value, and that will keep the new answer equivalent to the original fraction. And then the other situation involves converting between mixed numbers and improper fractions. Improper fractions and mixed numbers represent the same amount. It's just a little bit different way of writing them depending on the situation that you're working with. So just be aware of the process involved in going in each direction when you are doing that conversion between those two types of numbers as well. If you have any questions, please reach out and let me know. I'm happy to help. Otherwise, thanks for watching the video, and we'll see you in the next video.